Hi, I'm Andrew M. Radin, and I'm the Chief Business Officer and co-founder of twoXAR. So what we do at twoXAR is we discover drugs for complex diseases, and we do that all in computation, so we have no wet labs. So I'm Andrew Radin, and my co-founder is actually named Andrew Radin as well. We met a few years ago, I think 7 years ago, when I tried to buy AndrewRadin.com. He told me to get lost, but over the years we actually found out that we aligned on many other things besides just our name, from science to technology and ultimately to entrepreneurship. While I was here at MIT Sloan, we did a trip to Silicon Valley to visit companies and learn how startups work. And I actually had the other Andrew Radin come speak to my class. And that was the first time I finally met him in person. So my co-founder and CEO, he's been a CTO for startups for several years. Those startups have been in the large-scale computation space, so solving very hard, large, big data problems, from location to advertising to gaming. So it was about 7 years from when we first met to when we actually started a company together. But it kind of accelerated once I went out to visit in Silicon Valley and he spoke to the class. After that, we actually had started talking more and more. He was actually advising me on a mobile startup that I was doing here at MIT. And just before I was graduating, I said, look, I'm going to wrap up this project. I'm not going to work on this company anymore. He said, that's great, because I'm thinking of starting a company in the biology space. And from what I'm aware, those are your interests. So, let's see if this is a good fit. He flew out here. We spent a couple days actually in Sloan in a conference room, kind of whiteboarding all of this and saying, how does this technology actually translate to the real world? Is this something that pharma companies would actually get on board with, either as a software as a service, or can we develop drugs that they can license out? And so that's something we kind of explored for a couple days straight, and actually in a boat on the Charles River out of the sailing pavilion, we decided that we were going to do this. So our technology works in kind of a 4-step process. So the first step is collecting data. And that type of data is biological data, chemical data, clinical data, and subsets of those data include things like gene expression microarrays, protein-protein interactions, drug structure or chemical structures, and binding profiles of drugs with proteins in the body, as well as clinical data to look if a drug might be protective against another disease. Any of those data sets independently might not provide enough information, but when we look at the overlap between those data sets and the relationships, that's where we come up with a strong signal. And so our algorithm actually takes that data, puts it into a model for a specific disease, and we don't have to write any new code for every new disease. We just plug in a different data set and out come the results. One of our input data sets is a drug library. So we often work with one of these drug libraries of 25,000 compounds. And so the output of the system is actually all of those compounds ranked on their probability of being efficacious to treat that disease or not. Most of those drop off because they're just not related, but the ones that are in the high 90s or high 80% are ones that we spend a lot of time digging into. The drugs that look highly probable, we'll take those and we run animal studies on them to demonstrate efficacy. So one of the things that we sell on is that we can turn 6 years into 6 minutes. People gasp at that, both in good ways and bad ways. But what's really exciting is when we tell them stories about how we've actually done this. And we continue to do this.